So 2014 sample paper G, question 5. They've given you a sine graph here. It says the graph of sine 2x, and they're asking to plot two other sine graphs, g of x, which is sine x, and h of x, which is 3 sine 2x. And so these are called transformations of the trigonometric function. So there's kind of a few things you need to know before you can do one. So you need to know the period and the range of a sine graph. Period of a sine graph is 360 degrees, or if you're doing it in radians, 2 pi radians. And what that means, the period means the time it takes for the graph to complete. So one complete sine graph, if you can see this over here, goes up to the top, back to the center, down to the bottom, and back to the center. So one kind of wave is one graph. And that's the period. So for a sine graph, period should be 360 degrees. And then the other one is the range. And the range for a sine graph goes from -1 to 1. So that's on the y-axis from -1 up to 1. Okay? So the first graph we're going to plot is the straightforward sine graph, which is the one I'm talking about over here. So it has a period of 360 and a range of -1, 1. I always think the easiest way to do these is literally just take your calculator out and plot them. And this 180, or sorry, the pi is 180 degrees, which means this point here is 90 degrees. This point here is 270 degrees, and then the 2 pi is your 360 degrees. So if you take your calculator and you type the sine in 90, you get 1. Might do this in a different colour. So that's 1. If you go sine 180, you get 0. If you do sine 270, so at 270, you're going to get -1, which is there, and then at 360 you're going to be back to 0. So this graph here, the sine x graph, goes to 1, and then 0, and then down to -1, and then up to 0. So that's the sine x graph. Now the 3 sine 2x graph, you can kind of do the same thing. So the way this works, so just talked about sine x there. So 3 sine 2x. The fact that, so in this one, this is a 1 and this is a 1. It's 1 sine 1x, whereas down here it's 3 sine 2x. So essentially the 2 affects the period and the 3 affects the range. So what the 3 does is the easier one. Instead of the range going from -1 to 1, it goes from -3 to 3. The period, so this is 2x, instead of up here it was just 1x. So when you multiply this by 2, you half the period. So the period is 180 degrees. So you'll notice up here the original graph that was given was a sine 2x graph, so it was 1 sine 2x. So because it's 1 sine 2x, there was no effect on the range, so it still went from -1 to 1. But the sine 2x would have halved the period, and the entire graph, if you can follow this, up to the top, down to the bottom, and back, was finished in 180 degrees, which is what I said the period would be. Okay? So this graph, this second one that we're trying to draw here, this 3 sine 2x, it's going to have the same period as the one in black that we were given, but it's going to go up to 3 and -3. So here, where it's at 1, it'll go up to 3. Where this graph was at 0, the new graph would be at 0. Here, -1 would become -3. 180 here will still be 0. Here, back up to 3. Here, back to 0. Here, you're down to -3. And here, back to 0. So the graph looks like... Oh. Something like that. Okay, so hopefully that makes sense because there's quite a bit in that